I'd like to thank everybody for coming tonight. It's a great night. Unfortunately, a bad night to sit inside, I think. But if you can bear with us for maybe about an hour here, I'm hoping to get through the material we need to in that time. Might take a little bit longer if people have questions that they want answered, but I'll assure you that any questions you have, whether we take them as a large group or whether we cut questions off and I have to stay after to answer any individual questions, I'll stick around as long as I need to help offer any advice that I can. Just a little bit of background about myself. My name's Kevin Masarik. I work for UW Extension. My office is based out of the UW Stevens Point campus. That's where all the samples that were submitted for this testing program were brought to. We have a lab there that did the analyses. The main reason we do these programs is to help well owners such as yourselves learn a little bit more about the water quality that you're using, maybe for drinking and cooking, certainly for washing clothes and other activities. These programs offer you an opportunity to learn about your individual well water quality. But the second reason why these programs are really important is it offers us an opportunity to learn a lot about well water quality in the community. Testing an individual well is great, but that provides little insight into kind of community-wide groundwater quality issues. So testing is a large group. We had 152 people participate in this program between the 3 towns. That many samples at one time gives us a better ability to kind of diagnose what water quality issues might exist in an area, and then offer solutions or offer opportunities to learn more about what to do when those issues arise. So I'd like to thank everybody for participating. Hopefully by the end of the presentation you'll feel a little bit more comfortable interpreting your individual results and learn a little bit more about groundwater quality in the 3 towns. And the 3 towns that participated were the towns of Jacksonport, Sevastopol, and Sturgeon Bay. These programs are offered in conjunction with the Door County Environmental Council, who's been doing a great job over the last couple years of working their way from north to south down Door County, trying to organize or arrange these testing programs and allow people like yourselves an opportunity to participate. So I just want to acknowledge them. And I also want to acknowledge the towns, especially the town clerks like Linda, who's our camera operator today. They're the ones that really are critical for distributing bottles, collecting the bottles, and driving them back to Stevens Point in a timely manner. Just to kind of orient everybody, the maps are a little washed out. I'll put this presentation online if you want to investigate some of the information of the maps in a little bit more detail from home. But this shows the areas that we focused on. The shaded region represents the 3 towns, and then this is just an enlargement of what those areas look like. So here we have the city of Sturgeon Bay. We have Highway 42 running up the western portion. We have Highway 57 running up the eastern portion. Here's Jacksonport, Sevastopol, Sturgeon Bay, town of Sturgeon Bay down here. So kind of get oriented to where you're located on this map, because as we go through the presentation, we won't display the results to an individual parcel level, but we'll display them to kind of a 40-acre, quarter section level detail. And this allows people to just kind of get a sense for how their water quality compares to everyone around them. This map shows anywhere where there's a number represents a 40-acre parcel or quarter section that we received a sample from. So you'll see in some instances there's a number 1, which means there was 1 sample submitted from that region. In some cases you'll see a number 3, 2, or 4. And in those cases we receive multiple samples from that unit area. If you know where you're located on this map and it doesn't look like the results line up with your actual information, it's probably because we received multiple samples and we'd be displaying the average of all the samples we received from that area. But what this map shows is we got a pretty good spatial distribution across these areas. Obviously the samples were concentrated along the coasts And that just kind of fits with where the majority of the households are going to be located in the 3 towns. So no surprise that we receive more samples from the more populated regions. When we talk about groundwater, I'm not going to belabor the point, but our groundwater doesn't come from Canada. It doesn't come from Lake Superior. Groundwater is just rain or snowmelt that infiltrates down through the soil, eventually reaches a point where all the empty spaces in the soil or the cracks in the rock are completely filled with water, and that's our groundwater. So groundwater is a really local resource. Good chance that the water you're using for drinking and cooking probably came from within, a quarter to a half or maybe a mile within the recharge or within the area of your well. Groundwater is always moving. Once it's in the ground, it's always moving very, very slowly. In the shallow aquifers, groundwater is going to be moving from what we call recharge areas, those areas where the water infiltrates, and it's going to be moving to a nearby discharge feature, usually a spring, a river, a stream, or a lake. And aquifer is the term we refer to when we talk about our groundwater storage unit. It's a kind of the geology is what holds and stores our groundwater. So we have different layers of geology or different aquifers in Wisconsin, starting with the sand and the gravel. Those are materials left over by the glaciers. Over here in eastern Wisconsin, we have this eastern dolomite, which is going to be a critical aquifer for the people of Door County. Below that, we'll find some other layers of sandstones and dolomites. And then underlying the whole state, if we dug deep enough, we'd eventually find what we call crystalline bedrock, types of granites and other really impermeable types of rock that don't hold a lot of water. This is our basement, so there's not a lot of water in the crystalline bedrock, but there is a lot of water stored in the empty spaces in the sandstone, in the cracks in the dolomite, and in the spaces in between the sand and the gravel. Understanding the aquifers is really important for understanding how quickly groundwater moves and how easily groundwater becomes contaminated. So if we think about water moving through tiny spaces in between sand particles, that water is going to move much more slowly than water working its way through large crevices or cracks in the rock. So if the water can seep in or move through those materials quickly, there's a higher likelihood that those contaminants are going to be able to be transported or move quickly through that material as well. And that's very important for us here in Door County. Most of the wells are going to be installed into the Silurian dolomite material, and this should be kind of a familiar sight for all of us. This aquifer, that dolomite, is highly fractured. Those fractures tend to be well connected, and in much of the county, we don't have a lot of soil or what we call unconsolidated materials left by the glaciers. If we don't have a lot of soil, our ability to filter out things like bacteria or filter out pollutants or other contaminants is very limited. So areas where that soil layer is thin or absent, and we have underlying that material, that fractured dolomite rock, those areas tend to be highly susceptible to kind of rapid infiltration and potential contamination by land use activities. So we have to be extra careful in these areas of what we do. This is just kind of a broader look at how those layers look. This yellow layer is going to be the unconsolidated materials left by the glaciers. Here we have a Silurian dolomite layer, and we see that if you're on the eastern portion of the Door Peninsula, that unit is much thicker. And as we work our way over to the western portion of the peninsula, that layer starts to peter out. So depending on what side of the peninsula you're on, you might kind of determine which aquifer you're pulling your water from. If you're in this portion, probably a pretty good chance that you're pulling from that susceptible aquifer. This shows the towns of it's a depth to bedrock map. So the depth to bedrock, basically areas which are red or pink means that soil layer is probably less than 5 feet. There's a high probability it's less than 5 feet thick. And that's probably not a surprise to a lot of people. Areas where you see exposed bedrock, that tells us that the bedrock is relatively close to the surface. Here we have the unconsolidated materials are a little bit greater in depth, 50 to 100 feet. There's some of these orange areas where it's anywhere between 5 and 50. But generally speaking, the soils here are not very thick. Just another diagram showing that groundwater moves. It moves following the topography typically, high elevation to low elevation. So we just have to consider that there's kind of 3 dimensions to how groundwater moves, but generally moves from recharge areas to those discharge features. And we use wells to access groundwater for our households, and municipalities use wells to access water for their citizens as well. Here's the elevation map. We said groundwater generally moves from high to low. So if we use this as kind of a guide, this map is a water table elevation map, which kind of gives us a sense for how the groundwater is moving in this area. And we see that towards the middle of the peninsula, the water table elevation tends to be a little bit higher. And what that tells us is that if you're on the west side of the peninsula, the water is probably moving to the bay. And if you're on the eastern side of the peninsula, there's probably a higher likelihood that the water is coming from the middle and moving towards the lake. And if you live near a little river, stream, or creek, the groundwater is probably taking a shortcut, moving to that river or stream, and then out the river or stream into Lake Michigan. When we talk about wells are pretty critical for providing good water quality. The DNR regulates well construction, and the well code is based on the premise that a properly constructed well should be able to provide bacteriologically free water without the need for treatment. I'd say in some areas that is more difficult than others, but I think the nice thing about these slides is that all we think about when we think about our well is probably that upper 12 to 14 inches that sticks out of the ground. This diagram does a nice job of showing all the other components of a well water system that we can't see. That metal pipe that sticks out of the ground also extends a surprising distance below the ground. That casing serves an important function, which we'll talk about in a little bit. There's connectors that connect the well and the well pump that brings water into our homes, connects to the pressure tank. All these components, over time, the older a well gets, the more chances, the more opportunities there are for these components or components of the well to deteriorate over time. So when we're dealing with water quality problems, I think this diagram does a nice job of illustrating how complicated well water systems are. And as great as it would be if we were all professionals, well water professionals, able to fix problems, just know that there comes an opportunity or a point in which calling a certified or licensed well driller or pump installer is probably worth the money. Because these are complicated systems and they have the proper training to really diagnose better than we do a lot of times what might be happening or going on. This diagram on the right is for shallow sand point wells, some people call them. That's not going to be something that's very common in this area because, again, the bedrock is relatively close to the surface. And these types of wells really can only be installed in areas where the sand and gravel aquifer is what people are using to access water. So most people are going to have an installation like the one on the left, which we refer to as a drilled well. Drilled wells are going to have a casing of probably about 6 inches or greater in diameter. And there's some very simple things that we can do at the surface to try and provide good quality water. Again, this is an example of somebody's well. And as unsightly as that pipe looks sticking out of the ground, I always discourage people from trying to cover it up and disguise the well. Because anything that disguises the well from us seeing it is going to provide cover for things like rodents or rabbits or other animals that might want to seek out some sort of shelter. And we don't want to necessarily provide an encouraging environment for things like rabbits or other animals to kind of inhabit. So I've seen those kind of plastic rocks that people get that they cover up the well. Those things might look like a good idea, but I think in the long run, those are things that probably cause more problems than they solve. Even planting shrubs or trees around that well, we have to consider what's happening with those shrubs and trees below the ground. Those roots are working their way through the soil, and sometimes they can interact negatively with the casing. They can, if there's cracks or if there's compromised casing, that root structure, those root systems might try and work their way into those defects or those compromised components of the well water system. So again, as unsightly as this looks, I do encourage people to try and keep that free and clear. If your well cap is ever loose, if you go to your well and you kind of rattle the well cap, if that's loose or if it's missing or if it's cracked, that's one easy thing people can do is to get that fixed or have someone come out and install what we call a vermin-proof cap. If your well is really old and you don't have kind of a rubber gasket around the top of that well, consider having somebody come out and installing what they call a modern-style vermin-proof cap, which is going to prevent insects and other things from crawling into the well. Other things to keep in mind, if you don't know your well construction, any well drilled after 1988, you can actually locate your well construction report online. Prior to 1988, well construction reports were required to be filed with the state, but those are paper copies. Many of those paper copies have been scanned and are available for searching and locating, but prior to 1988, it's much more difficult for the average homeowner to kind of locate their well construction report. If your well is really old, let's say 50, 60, 70 years old, it's possible there's a well construction report, but the older a well gets, the more difficult it becomes to locate that file. And why is a well construction report important? Well, it tells us things like how deep the well is, the types of materials the well is drilled into, the location of the water table below the land surface. Those are all good pieces of information to know, especially if you're dealing with some sort of water quality problem. They provide additional information for people like myself to better understand what the issue might be. So transitioning a little bit, we talked a little bit about the importance of well construction. I want to transition into kind of the water quality side of the presentation. And water, we call the universal solvent because water naturally wants to dissolve stuff. And we all want pure water. Everybody wants pure water. But in the natural environment, we never have pure H2O. Water is always going to have impurities in the water. Those impurities depend on the types of rock and minerals that the water has to move or infiltrate through. It depends on the types of land use where the water recharges. It even can depend on the types of plumbing and packaging that the water is stored or transported in. Some impurities are not a concern for health, but others are. When impurities reach a point where they're a concern for health, we call those things contaminants. And then we have drinking water standards that allow us to compare our levels to what we consider to be acceptable or safe levels for drinking and cooking purposes to help us to decide what we might want to do or what recommendations to make about the use of that water. Just as water dissolves stuff, we can also treat water to take those unwanted, maybe health contaminants or aesthetic contaminants. We can treat water to take those unwanted things out. And many of us in this room probably have some sort of water treatment, such as a water softener, maybe a reverse osmosis system, maybe a carbon filter on the tap. Those are all examples of water treatment devices. And we'll talk a little bit more about treatment as we go through the presentation. The results or the tests that we offered through this program was a fairly extensive set of analyses. It's much more than people probably have done in the past if they've tested their water. For some of these things, testing once might be all you need to do for a while. There are other things that we encourage people to test for more often. And the other thing to point out about the tests that we offered is some of the tests are important to health, and there's other tests that we do simply for learning about the aesthetic qualities of the water. such as are there any taste, color, or odor issues associated with your water, and at what levels. And then there's other categories of tests that are just important indicator tests. Things like the saturation index are tests that tell us how the water might interact with the plumbing system, for instance. So just keep in mind that not all the tests that we ran have a health standard associated with them. Some of the things that we tested for are just a way to provide a little bit more information about aesthetic issues that you might be dealing with. And there are, the ones in red are things that are influenced by human activity. And just know that there are naturally occurring compounds in the groundwater or the bedrock. And some of those naturally occurring compounds can be concerned for health reasons. When we talk about health concerns, I think it's really important that we distinguish between the two types. There's acute health effects, which are usually seen with an exposure to a substance over a short time, or the health effects are noticed after a short time of exposure to a substance. So does anybody remember the cryptosporidium outbreak in Milwaukee? Or heard maybe an E. coli or a salmonella outbreak in the news? Those are all examples of acute health effects related to something like a bacteria, where maybe a couple days or a week after ingesting the cryptosporidium or the giardia, people started to develop symptoms, usually gastrointestinal type illness diseases. That's opposed to what we call chronic health effects, which are going to result from exposure to a substance over a long or extended period of time. So in the case of chronic health effects, arsenic or certain levels of pesticides, if arsenic or pesticides are in the water at a certain concentration above the health standard, if this is your primary water supply for years or decades, those people are at an increased risk of developing health complications later in life. Does it guarantee that you're going to get sick from drinking the water? Certainly not. But the health or the research studies show that certain populations that are more susceptible at these levels might be at greater risk for developing health complications. So when we start talking about chronic health effects, I think it's important that these are things that we be aware of, we be concerned about, but we not be overly alarmed about. Especially if we consider how much we're actually using the water for drinking, how much water we're actually getting from our well, and are exposing ourselves to these concentrations. Drinking the water once or twice, or if you're up here for only the summer season, those are all things we have to take into consideration when we're talking about exposure to some of these different chronic related health effects. And just to put it into perspective, when we talk about risks, drinking water quality is a risk, but it's really only one part of an individual's total risk that we face in our everyday life. So I do like to put it into perspective. We're all concerned about cancer and our exposure to different compounds. If we look at national cancer risk factors, they break down into different categories. Environmental pollution, water quality type things. Yes, it is a risk, but it tends to be much lower of a risk than some of the other things that we expose ourselves to. So things like diet, things like exposure to tobacco products, viruses, those types of things are often a much greater risk than when we start talking about water quality. Just to put drinking water into perspective, how to think about these things, the one related to water quality is going to be arsenic. The standard is 0.010 milligrams per liter. If 1,000 people were using that water supply as their primary water supply for, let's say, years or decades, the health studies estimate that 3 out of 1,000 of those people would likely develop some sort of health complication later in life. For some people, that's a large risk. Other people might look at that and say, it's not really as much of a risk as I thought. Everybody's different, so I don't think there's a right way or a wrong way to interpret that information, but at least hopefully it provides some context for how you think about your water quality results. The other thing I want to emphasize is that there is a difference between private and public water systems. I grew up in Milwaukee. I live in Stevens Point. So I've always been on municipal water. Municipal water supplies have a water utility manager and a department that's required to test that water on a regular basis. If there's anything wrong with it, where it exceeds drinking water standards, they're required to take corrective measure to ensure that every drop of water distributed through that system meets all the drinking water standards. And that's quite a bit different than a private well. Many people that might move out to the country or rural area, and this is the first time they're on a private well, might not be aware of some of the responsibilities that come along with owning your own well water system. It's great that we don't, when we're on a rural well, that we don't have a water utility bill. But along with that, those wells are not required to be regularly tested. So the fact that you're here today is strictly voluntary. If we do find anything wrong with your water, you're not required to take corrective action. So this is an educational program designed to kind of introduce you to your water quality and provide some additional steps that you might take if we find anything wrong. But we're not going to follow up with you to ensure that you took any corrective action. You as a homeowner are kind of your own water utility manager. But with that comes a lot of responsibility for interpreting the water quality results and then deciding what those next steps might be. So getting into the specific results, hopefully a lot of people brought their results with them. If you have your results, you can take those out at this time, and we'll go through kind of some of the most important tests. We won't go through all of them, but there are some that I think it benefits to provide a little bit more interpretation or information on. And the coliform bacteria test, this is what we generally consider to be the most important test to do or perform regularly on a private well. The well code, again, is based on the premise that a properly constructed well should be able to provide bacteria-free water without the need for treatment. Coliform bacteria are an indicator organism, so when we find them, it doesn't mean that you're going to get sick from the water. But what it does say is that there's a pathway for bacteria and potentially harmful organisms to enter that well or that water system. And we encourage people to really understand what might be the source of that bacteria. Because if there's coliform bacteria, the danger is that these other harmful organisms, things like Giardia, Cryptosporidium, Salmonella, those organisms have a greater likelihood of finding their way into the well. And in an area like Door County, where we have a lot of people on private wells and we have a lot of septic systems, maybe we have areas where we're spreading manure or other livestock are located. Those are all things that we have to be concerned about. So as a precaution, anytime we detect coliform bacteria, we do recommend people use an alternative source of water until a test indicates your well is free of bacteria or until you can locate the source of that problem. And that's recommendation is more of a precaution. Again, somebody might have bacteria and say, well, I've never gotten sick from drinking my water, and that very well might be. If the bacteria are not one that is likely to cause disease, it might not be something that would make you sick, but it is something that we generally like to urge caution with. If we ever detect coliform bacteria, we also check that sample to see if that bacteria is specific to E. coli. If we ever detect E. coli, then this is confirmation that the bacteria, the source of that bacteria was some sort of human or animal waste. We're not able to tell with this particular test if it's human or if it's animal. This is kind of a general indicator of fecal animal or human waste. So unfortunately, you can't get at the source, but it does tell us that there's some sort of human or animal waste entering the water supply. And this is a situation that we take much more seriously. Anytime there's human or animal waste entering or in our water system, there's a much greater likelihood that there's other unwanted organisms that will and do make people sick. And E. coli is certainly something that can make people sick as well. So if we detect E. coli, we do tell people to avoid drinking the water until they can determine what the source of that problem might have been and take corrective measures to make sure it's not a continuing problem. When we look at where we had bacteria positives, I wouldn't get too overly concerned about if you're located next to one of those dots or not. Most of the time, bacteria positives a lot of times can be related to the well construction itself. If we were to test every well in the state of Wisconsin, about 15% of them would come back positive at any given time for coliform bacteria. Again, mainly a function of well construction in a lot of areas. In Door County, it is also going to be a function of the geology. Because the geology is susceptible, we do tend to find higher incidences of bacteria positives in this part of the state. I don't know if that necessarily held true for this round of testing. It looks like of the 152 samples, we were right at about 15% that came back positive for coliform bacteria. This probably, I do urge caution because other work that we've done, I'll come back to some of this. Other work that we've done in similar geology down in the town of Lincoln over in Kewaunee County, we tested wells monthly for coliform bacteria. We actually did counts on those samples. And what we found is that 1 month that well would come back positive. And maybe so this is positive, the next month it was positive, positive, and then the next month it came back negative, negative, negative. So bacteria in these types of geology or geologic settings can vary quite a bit from even month to month. So just because you had an absent bacteria test, it might give people a false sense of safety over the course of the entire year. In this type of setting, in this type of geology, checking the bacteria maybe a couple times during the year might have some benefits for getting a better understanding of water quality, especially if you're using it for drinking or cooking. Because what this tells us is that from month to month, even maybe from week to week, the water quality might be pretty variable. And there are times of the year where we'd be more concerned that there's this rapid infiltration of surface water into our aquifer. One time of year might be the spring when we get a lot of groundwater recharge. Another time of year might be the late summer, the fall, when we're talking about peak kind of tourism season here in the Door County region. So testing maybe a little bit more frequently for bacteria is something that I'd recommend just because of the area that we're in. These are other things to keep in mind if you ever get a positive bacteria test. We talked about the importance of a well cap. This is some poor wiring, and there's water that's kind of ponded around the casing. If we have other attachments such as livestock waters or yard hydrants that are attached to our well water system, if these components don't have proper backflow prevention, sometimes there's water that can be siphoned back into the well from these devices. And if we're siphoning water out of a livestock water or out of a yard hydrant, if we're siphoning water back out of those types of things, those are things that are going to carry bacteria into the well with it. So again, if you have additional connections, always make sure to check and see if you have the proper backflow prevention on those systems. And this is also an opportunity to plug anybody that has maybe an old farmstead or an old homestead where there used to be a well that served the house. If that well hasn't been properly filled and sealed, this diagram kind of illustrates why it's important to have that filled and sealed properly. In this diagram, say this is an old dug well or just an old well which is being contaminated either from runoff over the surface or some sort of underground storage tank or septic system. That contamination has a direct conduit into the well and down into the aquifer. If this is not properly abandoned and we drill a new well nearby, that source of contamination still exists, and it's continuing to contaminate the aquifer where we're pulling our water from. So if you know your property has an old dug well or an old unused well, please consider having that properly filled and sealed. It's a benefit to not only you, but also your neighbors. This just shows, again, the topography of the area. Anywhere where we have sinkholes and outlined in gray shows kind of the Niagara Escarpment. It extends all the way down kind of the eastern side of Wisconsin. Pretty prominent in Door County, and then it gets spotty as we get down into, let's say, Kewaunee, Brown, Calumet, even parts of Fond du Lac and Dodge County have very similar to geology to what you have here. But these are areas, again, that are incredibly susceptible to bacteria types of contamination. If you ever do have a positive bacteria, we encourage people to use an alternative source of water, retest to see if it's a function of sampling error. If this is something you're checking regularly and it's routinely coming back positive for bacteria and disinfection doesn't seem to be taking care of the problem, it might be something that you investigate or take a little bit more seriously. If it's related to the geology and it seems like it's impossible to get a safe bacteria test consistently, then you might think about alternative solutions that you'd consider, such as avoiding the water for drinking and cooking purposes, or maybe seeking some sort of approval for water treatment on your well that would specifically take care of or target the bacteria, the virus issue. For some people, if it's related to a sanitary defect or some sort of well construction fault, simply fixing that is enough to take care of the problem. After the well is disinfected, anytime you disinfect the well, you want to retest to ensure that the procedure was effective. When we talk about the next test, this is not a test that's a concern for health. Hardness is something that's mainly an aesthetic problem. Hardness is basically calcium and magnesium that comes from the dolomite type of rock that your well is installed into. Dolomite has a lot of calcium and magnesium, and too much of those minerals can cause issues like scaling, soap scum. People with hard water tend to use more detergent, and hard water over time can decrease the efficiency of a water heater. If we think about a scale formation, a scale forming on an electric water heater coil is going to act like an insulator, and that water heater is going to have to work much harder to heat water to the desired temperature. So for these reasons here, most people with hard water are going to install a water softener. And if I have a show of hands, how many people have a water softener at home? I would say the majority of people in the room would qualify for what we consider to be hard water. Anything greater than 200, that's the threshold where water softeners are probably going to be, people are going to notice a benefit from having one of those installed. When we talk about water softeners, it's a very common, fairly tried and true technology. They're going to remove the calcium and magnesium, but they're going to exchange it with a different ion, and that's going to be sodium. So just keep in mind that if you're softening the water, you're taking the calcium and magnesium out, but you are adding a little bit of sodium back in. So if your doctor says, I want you to really cut down on your sodium, might consider how much sodium you're taking in from your water softener. That's why a lot of people will actually bypass their drinking water faucet with their softeners to avoid having that additional sodium intake. Generally, it's not necessary to soften water for outdoor faucets. The plants really don't care if your water's softened or not, and it's just a waste of a lot of salt. There are, if you do have to drink softened water, there are alternatives. Potassium chloride, a little bit more expensive, but maybe healthier if you're going to be using that water for drinking. This shows the total hardness. So in this case, the different colors or the different letters, if you have trouble kind of visualizing the colors, correspond to different concentrations of hardness. We said that 200 was kind of that cutoff for what we consider to be hard water. 300 to 400 is the red, and then above 400 is the black dot, or the F. And there is kind of a general pattern. It looks like over here on the western side, water tends to be more in that 300 to 400 range. And over here along the shoreline, we see water with a little bit less hardness or less calcium and magnesium. When we talk about how much salt people are going to use, I always hear from people that say, there must be something wrong with my water softener because my son or daughter uses half as much softening salt as I do. And we have to keep in mind that how much salt you use is going to be related to how much hardness you have. If you have 200 and your neighbor, your son or daughter has 400, they're going to have to use twice as much softener salt to reduce or remove the level of hardness in their water. So sometimes it's not necessarily related to the functioning of the device, It's probably more related to where you have to set your water softener to begin with. These are overall water quality tests. I'll let you read about these in the interpretive information that we provided. Alkalinity is just the ability to neutralize acid. It's roughly equivalent to the total hardness value. If your alkalinity value is really high and your total hardness value is really low, that tells us that you collected a sample from a softened source. Conductivity is general. Well, why is that important? Well, if you submitted water from a softened source, you can probably estimate your hardness by looking at your alkalinity value, because those generally occur in roughly equal ratios. Conductivity is the measure of total ions. Conductivity is usually about twice the hardness value. Conductivity is a good way to kind of track water quality over time. It's a fairly simple test, and it just tells us how much total dissolved stuff is in your water. And rapid changes in conductivity might indicate kind of sudden surges of surface water into the aquifer. pH is something we've probably all heard of. It gets at water acidity. Things that are low pH are acidic and have a greater tendency to corrode plumbing, and things that are above 7 tend to be more basic and more likely to cause or form scale formation. Those three tests are combined into what we call the saturation index, and that's simply a measure of corrosivity. If you submitted a softened sample, just be aware that the saturation index is probably going to, it's not going to be correct. If you submitted a softened sample, it's probably going to say your water is corrosive when it's likely not going to be. The other things that we're going to talk about from that homeowners package are related to land use. And anything we do in the landscape has the potential to contaminate the water below. We talked about the importance of soil. Thicker soils offer more protection than thin soils. Heavier textured soils like loams or clays offer more protection than, let's say, sandy soils, which the water can move through quite rapidly. So whether we're talking about septic systems, lawn care, agricultural practices, all those things are potential sources of nitrate and chloride. And if this is your well, chances are your water quality is being influenced by what someone upgradient of you is doing on their property. Yeah, correct. Yeah, so if you own a mile or more, then you might control your recharge area. But if you're on a 2-acre or a 5-acre parcel, there's a high probability that your water quality is being controlled by one of your neighbors. So I think this is just a plug that we should all try to strive to be as best of a neighbor as possible, because we're all kind of in control of this resource here. Nitrate is a very common test. We do this test, one, because there's health effects related to nitrate, particularly targeting infants and women who are pregnant. There's methemoglobinemia is the term for blue baby disease that targets infants, and it's also been linked to potential birth defects and miscarriages, not only in humans but also in livestock. And then nitrate, because it moves so easily and readily through the soil and through the groundwater, we consider it to be a really good indicator of other potential contaminants. The sources of the nitrate are going to be fertilizers. If fertilizers are getting into our water, we have to assume there's a greater likelihood that we might find pesticides in the water. If septic systems are the source of the nitrate, then we might consider personal care products or pharmaceuticals or viruses to be more likely to end up in our water supply. Same with animal waste. Animal waste might indicate a greater potential for bacteria to find its way into our water system. The standard, we say anything less than 2 is kind of natural or background levels of nitrate in groundwater. Anything above 2 is seeing some impact by human land use. And then anything greater than 10 we consider to be in exceedance of that standard. Again, primarily infants and pregnant women should avoid water over 10. We encourage everyone to avoid long-term consumption of nitrate above that level. This slide actually shows that regarding nitrate, these 3 towns actually are sitting pretty good. Blue, any of the light or the dark blue are less than 2, and that makes up 69% of all the water samples that were submitted, showing kind of background or natural levels of nitrate in groundwater. There were, roughly 30 or so percent that were elevated. There was actually only one that came back above the standard. If we look statewide, the statewide average for wells that exceed the drinking water standard is about 10%. And in the case of these 3 towns, these results show that we're sitting at less than 1%. So when it comes to nitrate, the water quality in these 3 towns actually looks quite a bit better than many other parts of the state that we perform these programs in. Something to be aware of, especially if you're in the, if your dot is green or orange, where it's showing impacts, just like the bacteria, the water quality in this area is quite variable. You might consider testing nitrate again sometime in the near future to see if that level fluctuates. If there's none detected, I think it's unlikely that we'd see a large fluctuation. But if you're detecting nitrate, those wells are more likely to see some fluctuation in the concentration over time. So something to maybe pay attention to just to see it or ensure that it doesn't creep up over time. This is the land use map. We see, in the middle of the county or the peninsula here, we do have a higher concentration of agricultural activities. And if we look at our maps, we don't have a strong sample set from the middle, but we do see, maybe a little bit greater number of detects towards the middle. Again, though, with the density of septic systems around the shoreline, we can't rule out that septic systems would be the source of some of these elevated nitrate levels either. Nitrate, I'm not going to spend a lot of time on this because there was only one person that was at that level we'd be concerned about. But short term, changing or relocating the well might be a possibility. That can sometimes be a very expensive experiment, especially if your well is really new. You might want to try and seek out some alternative to spending money on a new well if you've just recently drilled a new well. Purchasing water might be an option. Otherwise, there's a fair number of water treatment devices out there that are specific to nitrate. If you're concerned about nitrate, be sure that you're looking at a reverse osmosis, distillation, or anion exchange. Things like water softeners, things like carbon filters are not going to be effective for nitrate. When we look at the chloride results, we say less than 10 is generally considered natural in much of Wisconsin. There are some areas where we have some naturally occurring chloride in the groundwater. Anything greater than 250 isn't a concern for health, but can sometimes give water a salty taste. And water with that much chloride would also tend to be fairly aggressive or corrosive. So just like road salt used to corrode vehicles or cars quite a bit, elevated levels of chloride, sodium and chloride in the water can also cause corrosion issues with the plumbing system. But what we see is that we didn't have, the blue, again, are going to be kind of the background or natural levels of chloride. And the majority of people were in that natural or background concentration, 62%. And there were a few, about 40% were slightly above that level, but there were none that were what I would consider to be excessively high. There was one that was in that 100 to 200 range, and when we see it at that level, a lot of times that's probably related to, it could be related to the geology, or it could be related to road salt applications as well. We salt the roads in the winter, it does a nice job of melting the roads, but that salt melts off into the ditches and then becomes part of our groundwater system. So sometimes if we see, rapid spikes in chloride, it might be an indication that the runoff from the roads in the wintertime is influencing our well. Transitioning into the metals, I'm not going to go through all the metals, but I do want to focus on some of the ones that cause the most problems for folks. The first one being iron. Iron is something that people don't like the taste of. This is probably the #1 complaint we hear about people with well water, is that when people talk about well water taste, a lot of people associate iron with well water. So not only does it cause taste issues, but it causes kind of those staining issues. Anytime we see kind of that reddish or orange or brown staining, that's going to be an indication of iron. And when our concentration of iron is greater than 0.3 milligrams per liter, that's when those symptoms start to be more noticeable. If we have iron present, there's also a greater likelihood of what we call iron bacteria. Iron bacteria can kind of cause the water to feel slimy, especially if you feel the inside of the toilet tank and it feels like there's a slime on the inside of the toilet tank. It might be an indication of iron bacteria. If you notice kind of an off-putting odor, water sometimes smells like sewage or rotten eggs, it might be an indication of iron or sulfate-reducing bacteria in your well. And if those are problems, there are ways that you can kind of control those issues through periodic chlorination, and there's documents or publications online that would help you address kind of iron or sulfate-reducing bacteria problems with your well. Copper, if we detect elevated copper, it's very unlikely that you're tapped into some sort of copper mine deposit below you. What's much more likely is that copper is going to be coming from your water pipes. Less than 1.3 is generally considered suitable for drinking, but too much copper and people that aren't used to drinking that water might notice problems with digestion or digestive type issues. Those problems might be more severe, again, in people not used to drinking the water or if there's infants using that water supply. With the copper, similar to the copper is going to be lead. There's no known benefits to lead in the human body, so the more we can reduce our exposure to lead, the better off we'll be. Prior to 1985, they actually used lead solder to join copper piping together. So this can sometimes represent a significant source of lead in some homes. You'll notice the standard is quite small, 0.015 milligrams per liter, and particularly young children, infants, are going to be particularly vulnerable. Nervous disorders, brain development type issues. Why the picture of the hose? I just put a reminder that rubber hoses and vinyl hoses sometimes use lead as a stabilizer. So allowing kids to drink from hoses is something I discourage. If we think about a hose sitting and baking in the sun over the course of a summer, that's really going to deteriorate or cause any elements to become more soluble. So I discourage people from letting young children drink from hoses for that reason. Other things about lead and copper, we asked you for that metals package, we wanted you to take kind of water that sits in the pipes for a longer extended period of time, because that gives us an indication of kind of the worst case scenario. What is the maximum level of lead or copper that you get from drinking your water if, let's say, you woke up in the middle of the night or first thing in the morning and opened up the tap and filled up a glass and took a drink. So with that in mind, the easiest solution to lead and copper issues is simply to allow the water to run for a minute or two before using it for drinking or cooking. If it's because it's sitting in contact with the pipes, if we allow that stagnant water to flush out, what we see is that we greatly reduce those concentrations to almost nothing simply by flushing that water out of the system and pulling water from the pressure tank or the well. So that's the easiest solution. If people aren't confident or don't want to bother with that, there are treatment devices, but they're generally not necessary for copper and lead issues. This is something that a lot of people had questions about because we did detect, if we look at our sheet, there were about 11%. So of the 126 people that had the metals package performed, there were 14 that had levels that measured above the standard for arsenic. Arsenic is generally going to be naturally occurring. I know because we're in an area where there's cherry orchards, there's kind of some historical concern about lead arsenate. I feel that the lead arsenate is probably more of a soil issue than it is a groundwater issue, and that if we detect arsenic in the groundwater, we detect arsenic all over the state of Wisconsin in areas where there wasn't a lot of orchards or lead arsenate being used. So when we find arsenic, I think it's more likely that it's something to do with the geology and the bedrock itself than related to the land use. Again, these are possible health effects related to arsenic, And at the levels that we found mostly in these wells, they were just at or right at that level where the standard is. So I think it's something to be concerned about. I think it's something that if you detected arsenic, you might want to check for again in a year or so. And if it remains high, then maybe consider what preventative steps or actions you might want to take. But because the levels were kind of right at the threshold of where we can even quantify arsenic, I don't want people to be overly alarmed at the initial arsenic detect. Maybe wait again 6 months or a year, test again, and then see if you still find it in the water. When we looked at kind of the northern door portion of the peninsula, we didn't really find any arsenic in those northern towns. Therefore, I'm just curious, how much of it, how much of a concern is it? Was it a function of the time of year we sampled? Was it a function of the year in which we sampled? Because it's not something we found historically in the groundwater, I think the best advice I can give is it's something to be concerned about, but not overly alarmed about. If you found it, maybe that's incentive to check arsenic again in a year or two to see if it's still elevated or if it's gone, especially if it's gone up, then I think it's more of a concern. If it stays the same, then it's maybe incentive to do something about it. But you might find that in 6 months or a year you test again and it's not detectable or it's much lower. And then that's additional information you can kind of use as guidance for how severe of an issue that might be. So maybe not the clearest instruction. Some of the times when we talk about water quality, there's no real good answer to give to people other than to try and walk them through the process of how to make that decision. The last test that we offered was what we call the DACT screen. DACT stands for diaminochlorotriazine. That's a specific to atrazine type pesticides. So atrazine, simazine, propazine. You'll notice that atrazine is one of the most frequently detected pesticides in Wisconsin. We offer this screen because it's relatively inexpensive. If we wanted to test for all the pesticides or many more of the pesticides we find in Wisconsin, those tests get much more expensive. We're probably talking $125 to $200 if we wanted to look for these components and their breakdown metabolites, we call them. So the atrazine is just kind of a way to get some or collect some information on if pesticides are being found in the groundwater. And it provides a little bit more information to decide if we want to spend money on these more extensive tests for pesticides. Keep in mind that there's literally probably hundreds of pesticides out on the market. Not all pesticides have health standards associated with them. And usually the health standards only account for the parent compound. A lot of these pesticides break down into one or more what we call metabolites, which might have their own health complications. And we have very little research into what the health effects are from the combined effect of all these chemicals in the water. But specific to that DAC screen, again, it measures one of the breakdown components of triazine. So it might underestimate the amount of atrazine type compounds. The drinking water limit is 3 parts per billion. If a well ever detects above 3 parts per billion, those folks would actually be eligible for well compensation through the Department of Ag, Trade, and Consumer Protection. But when we look at the results of the DAC screen, we'll see that 81% of the people that had it performed did not detect any in the water supply. There were about 19% of the people that detected, kind of a trace amount of the compound. At these levels, it's unlikely that any of them would have exceeded that 3 part per billion standard for total atrazine. So DACT plus the parent compound and other metabolites. Again, where we find it, some of these darker blue dots, obviously the green dots, there's not really a concrete pattern to where we find it. My guess would be if it's atrazine, it's indicative of some sort of agricultural source. Atrazine isn't a compound that we generally use on lawns. So it would be an indication if you found atrazine, that there's probably some influence from upgrading to agricultural practices, but not to a level that's overly concerning or alarming. Certainly compared to other parts of the state, those are very low levels to what we typically find. When we talk about improving long-term water quality, keep in mind there's long-term solutions, but that might take years or even decades to notice any significant improvement. Therefore, especially when we're talking about health considerations or complications, we often have to look at what short-term improvements can be made to avoid or improve our water. Anytime we install water treatment, the advantage is that it reduces level of contaminants and other impurities. It improves taste and odor. But just keep in mind that those devices require routine maintenance. They're going to increase the amount of energy you use, especially if you're talking about something like a reverse osmosis system. That's going to increase energy use a little bit. And then, testing is often the only way to know if those devices are working properly. So there's additional testing requirements that you'd probably want to consider if you choose water treatment for a health-related contaminant. And then treatment is very specific, and sometimes, especially for something like reverse osmosis, pre-treatment with a water softener is often necessary to make sure it's functioning properly and optimally. I just put on the board, here's the website of our center. Tonight I will post the presentation online. So if you want to take a little bit closer look at the maps, those will be available. I would imagine the towns may post links to the presentation or the video as well on their websites. So if you want to take a closer look, if you know somebody couldn't make it tonight and wants to view the presentation or the video, they will have an opportunity to do so after today. So with that, before I open it up for questions, I just do want to thank all of you for participating. I think it was an incredible turnout, not only for the testing, but also for the presentation tonight. I want to thank the towns, and especially the town clerks, and then again, the Door County Environmental Council for all the work that they've done in arranging. If people have to go, I understand, but maybe we'll take 3 or 4 questions, and then if people have individual questions after that, I'll stick around as long as I need to help people out.
You said there's a website where we can check our well. So what's that website?
So the website where you can check your well, if you look in your folder, is it on here? What I would say, I have to revise this. Well, actually, it is on here. I would start at the Wisconsin Geological Natural History Survey. They're the ones that historically have done a good job of managing well construction reports. And they do have a process where they will, for a small fee, they will locate somebody's well construction report. I believe they also have links to the DNR where you can do an online search on your own, or DAGCAP, which has a search tool for historical records as well. So I would start there. Actually, there's a document. Okay. Yeah, that you have to send in, but on their web page, they should have the links to where you can access that information online. Any other questions? Sure.
You said you might want to get a bacteria test again, the spring, fall, whatever, something like that. Where would one do that? I think the county just tests for nitrates.
The village of Ephraim has a certified bacteria testing lab. So that is one location. The DNR also has a list of certified bacteria tests or testing laboratories online. I know Ephraim's the closest. There's probably a couple out of Green Bay. Our center, or lab at UWSP, people can call the lab at any time of year, and the lab would mail you a kit, and you would then need to mail it back. Mailing is a little bit tricky sometimes because there is kind of there's a 40-hour window for when we need the sample back in the lab. So between the time it's collected and the time we get in the lab, we need to receive it within 40 hours. So mailing from Sturgeon Bay can sometimes be tricky, and I'm a little worried with all the post office, kind of the distribution centers closing. I don't know how that's going to affect the mailing time in the future. Historically, we've had a pretty high success rate of somebody mailing a sample late in the afternoon, getting it the next day or the day after within that 40-hour time frame. But as we move forward, again, I think challenges at the post office, there might be some benefits in going with a local laboratory for bacteria. And again, I think the village of Ephraim is probably the closest lab for that. Sure.
I just want to add to that. You can go in the county sanitarian's office and you can pick up a kit that you can take to Ephraim, or you can pick up a kit that goes to Casco. There's a lab in that.
Perfect. Is it Luxerin or?
I don't know where. I just know it's
In Casco. Okay, so that's another convenient option. Thanks for offering that. The more for us, it doesn't matter where you send the sample. We're all typically doing the same type of method, and we're all certified by the state. So it's whatever most convenient for the homeowner. The prices are going to be relatively comparable. For this set of tests, I think if you did all three, it was $113. You know, if you just do a bacteria test, you're probably talking $20 to $30 for a bacteria test. If you're talking a nitrate test, that's probably $15 to $20 just for the nitrate test. So again, this was a fairly extensive set of analyses, probably not something anybody is going to do, you know, annually. But for those other tests that we do recommend on a little bit more frequent basis, that hopefully gives you an idea of what the cost is. And it's, you know, it is additional money, but you know, probably money well spent for a lot of people.
Can you talk a little more about the arsenic? And you indicated this was a little unusual from your prior study, and what your hypothesis might be about that.
Yeah, so it was a little unusual for other parts of Door County that we tested in northern Door. You know, geology can change as we work our way down the coast here. So, and it can change temporarily or with time from year to year. So, you know, I don't know if it's a function of the time of year that we tested, if it's a function of the year in which we tested. You know, dry years and wet years can cause fluctuations in the water table that can cause changes in chemistry of the water. So it's difficult to say at this point, you know, if that's the reason why it looks quite a bit different than the northern counties or not. I think there is a plan to work our way south in Door County, so there might be an opportunity next year to learn if this is a function of maybe the part of the county which the tests are located. Maybe there's something about the geology that is more likely to cause arsenic. You know, also I do want to mention that when we talk about levels that low, we are kind of pushing the limits of our equipment. So we are above what we consider to be the limit of detection, but we're kind of right at the level where we're talking about the ability to accurately quantify the arsenic level. So keep that in mind. You know, we did rerun some of the samples just to check, and they came back very similar, but they do at that really low level sometimes vary by as much as 2 or 3, well, 0.002 or 0.003 milligrams per liter. So if you're talking about somebody that tested at 11, if we were to test that same sample multiple times, one time it might come back at 9, one time it might come back at 11, one time it might come back at 10. So when we talk about those really low levels, just keep that in mind. And those standards are, I wouldn't say they're arbitrary, but 10 is a nice round number. So when we set these standards, you know, we try to set them with a certain amount of safety built in. So, you know, there are risks, but I think we have to put those risks in the context of all the other risks we face and knowing kind of how we get those numbers, knowing there's a little bit of variation in those numbers. My advice would be it's something that if you found arsenic, especially if it was above 0.010 milligrams per liter. Something to be concerned about and consider testing again, but at this point, not something to be overly alarmed about. And hopefully, you know, a long-winded answer, but I'm a proponent of providing enough information for people to make the decision rather than say this is a black or white issue. Sure, one more question and then maybe we'll adjourn here.
Does reverse osmosis take E. coli out of the water?
Reverse osmosis is not certified for bacteria or viruses because there can be those membranes. You know, it's a very those membranes are very small. They try to. It's kind of a way to filter out things. But if there's a breach in that membrane, if there's a tear in it, there's a possibility that those things can pass through. So they haven't been tested. They're not certified for bacteria or viruses. The only method I know of that has state approval for disinfection, and it does require DNR approval if someone wanted it installed on their homes, would be UV, ultraviolet light. And Laurel can correct me if I'm wrong there.
Ultraviolet or fluorine?
Or the addition of chlorine, which is what municipalities generally do. Those two would be the things effective for bacteria viruses. But keep in mind that, and again, correct me if I'm wrong, but those would require DNR approval. I'm putting Laurel on the spot here.
It's a site-specific issue.
Okay.
So if someone has questions, you can either talk to me or we could give you assistance through a DNR person.
And I would recommend, you know, the DNR staff is really, especially for private well owners, they really are a resource to help get you safe water. So consult with them. Not only, you know, are they good at what they do, but they bend over backwards to try and find a good solution for you. With that, you know, maybe I'll say we adjourn. And again, if anybody has individual questions, I'll stick around as long as I need to. Thanks again for coming.